I would like to thank San Murugesan and Elena Boyanova for inviting me to talk about the future of clouds for this special issue of Computing Now. I have been looking at the problems of clouds for maybe 8-9 years now, and in thinking about what are the future problems, I would like to start from the infrastructure itself. People usually start from what is seen, and that is these interfaces on Amazon and other Azure and other private clouds offered by HP, IBM, and others. But I think that one of the biggest impacts for the future of cloud will be coming all the way down from the infrastructure. Today's clouds are still based on traditional computers, servers with disks, but there's substantial disruption coming in terms of non-volatile memory. We at HP just happen to be working on memory store, but there are alternative technologies which will dramatically change the whole stack from hardware all the way up through the system software and applications. Primary reason being that disks were the main bottlenecks in performance so far, and once they are removed, there will be new bottlenecks that will arise, but the performance will be dramatically improved. So if you also think on the client side in terms of all these laptops that potentially shut down, now they can continue working on because of the persistent memory replacing the DRAM. That vision is still a number of years away, but it will have substantial impact on the clouds, not just for the performance reasons, but also for the power, which is one of the top bottlenecks in the cloud in terms of cost. Once you move up from the hardware, and it's not just the non-volatile memory, but also photonics that interconnect these vast amount of infrastructures in the cloud, and also new multi-core architectures, including systems on a chip. But once you go up from the hardware, the next is system software, and that one will also have to be redesigned. Linux is traditionally used, so one will have to re-implement parts of the Linux and other operating systems to recognize non-volatile memory, to understand how to drive these photonics and adapt to multi-cores and systems on a chip. And then going up the stack, the applications, especially the new applications, and we've been seeing new types of applications, especially streaming applications, and then also with Internet of Things, a number of events that becomes tremendous and generating a lot of what is being called big data, but that will also drive substantially the future of the clouds. If I think further, some other opportunities are in the areas of high-performance computing in the cloud. Up to now, the high-performance computing has seen only limited use because of the jitter that is not well suited for very large-scale parallel processing, and which, due to partially virtualization, partially randomness in allocating these virtual machines across the cloud, was the biggest obstacle. Then there's a number of other bottlenecks. Overall networking, bringing data into cloud is still a big problem. Then talking about quality of service, there are still no guarantees there. But also programming the clouds is a big deal. There's a lot of discussions have been a lot of discussions around mashups and things, but ease of use and ease of programming of clouds is still a big problem. Then there are a number of issues along the lines of business models, how to enable different businesses to exist and support each other in the cloud. And finally, the trust models, which about 7-8 years ago, while I was managing OpenSearch, a cloud computing test bed around 16 sites around the world, it was issued then, and it's still issued, whether we trust, both for the perspective of security and then also reliability. And that's one of the reasons why Amazon, Azure, and others have sites in different regions, because even if you trust the providers, if one whole region is taken down, your site as a collateral damage will go away, and you will have substantial cost. So as you can see, there are so many problems, but there's also a tremendous amount of research, including this study, and I thank again San and Irena and wish a good luck with this feature.